This is our first lesson in the unit of reviewing polynomial functions. So you could either print out this handout and fill things in, or take notes on a piece of binder paper to refresh yourself with the concepts of polynomials. So in reviewing this topic, we've got what is a monomial, first of all. A monomial is a number, it's like 5, or a variable, here I've got x, or some product of numbers and variables. -7 times x to the 4th. This is a product of the number -7 and x times x times x times x, 4 x's. So that's a product of numbers and variables. This is also a product of variables. I have p times p times p times t times t times t times t times t. And that's what this is. And so those are all monomials. Another way to think of it is one term. We're going to use exponent rules to simplify monomials. So let's refresh that. When you're multiplying like bases, you're going to add your exponents. So here's an example with the base of 3. They have to have the same base, though. You can't have 3 to the 4th times 2 squared. They have to both be base 3 or base whatever. The power rules, when we have a power statement, a to the m, raised to another power, we multiply our exponents, as you see in that example. Also, for the power rule, when we have a product of two things, a times b, raised to the m, you can distribute, because again, we're multiplying those exponents. So I'm going to multiply that exponent m times the ones of each of those bases. The quotient rule, when dividing like bases, you subtract exponents. The negative exponent rule means the reciprocal of. So if I have some base that is a over b, like this would be 5 over 1, okay, then the negative power, negative exponent means to flip the base. So instead of a over b, it becomes b over a, and now to the positive m power. And here we have an example of it. The zero exponent rule, anything to the 0 power is 1. And now we're going to do some simplification. So I put things together. I'm just going to reveal these, and you could pause the video and look at the steps of what I did. I rearranged things so that I have my numerals being multiplied together. Then I have my like bases next to each other so that I know that, oh, multiplication of like bases is to add the exponents. So 2 plus 6 is 8. And here, I wrote down each one of these 3 parts of this term, -2, a to the 3rd, and b, are each being squared. So there's my -2 squared. Right here is my a to the 3rd squared. And here is my b that's being squared. I've separated them all up so that I've put my numerals together, my base a together, and my base b together. And then I multiply everything out. I have my results. Again, pause the video so that you can examine these a little bit better. Here I am simplifying this fraction first, which is where I got 18 m to the 4th n cubed. And I'm subtracting 10 m to the 4th n cubed. Oh, they have exactly the same variable parts to their terms. So therefore they are like terms. And I'm saying I have 18 of these terms minus 10 of these terms is a grand total of 8 of these terms. These terms are m to the 4th, n to the 3rd. Here I just rearranged. I put my numerals together, 2 and 10. I put my bases together, k to the 4th and k to the -7th. Multiplying, I get 20. When I multiply these, like bases, we add those exponents. 4 plus -7 would be k to the -3. So I wrote k to the +3 in the denominator because that negative exponent means to flip. Problem number 5, I started off by simplifying this group that's being squared over here in the margin. So this first group is the same as 4/9 r to the 4th s to the 14th. And we're going to multiply it by this group. So I put my numerals together. I put my base r's together. I wrote my base sixes together, adding the exponents for the r's, adding the exponents for the s's, and then simplifying those numerals to over 27, you have your answer there. For number 6, I simplified what was inside the fraction first. 14 divided by 7 is 2. W to the 12th divided by W to the 3rd, you're going to subtract those and get W to the 9th. But on the outside of that group, it's to the -1 power, which means flip everything inside that group. So instead of 2, that would be 1/2. Instead of W to the 9th, I'd have 1 over W to the 9th. And so then I have this final answer. For 7 and 8, again, I am simplifying my numerals. I'm simplifying things that have the same base, x to the -2, x to the 10th divided by x to the 12th. 10 minus 12 is -2. And y to the 4th divided by y to the 3rd is just y. We don't want to leave things with negative exponents, and so x to the -2, that means the x goes in the denominator to the +2 power. And here, I simplified what was inside the parentheses first. C over C squared is 1 over C. 1 over C to the 4th is right here, 1 over C to the 4th. We're going to multiply it times -3C raised to the 4th. Well, -3 to the 4th would be a positive, because we're negative times a negative times a negative times a negative, and 3 to the 4th is 81. So it's 81 C to the 4th. C's cancel, and you're left with just 81. So that was reminding you, giving you some review of simplification. It's quite a bit that you could pause and double check all your answers in the work. Okay. We're going to go on to the next page, which is now talking about polynomials. We had monomials on the first page. Now we're going to talk about polynomials. So a polynomial is the sum or difference of many monomials. So we can have monomials connected by addition, or you could say connected by subtraction, but really I like to think of it as you're connecting everything by addition, or you're adding a negative term. The highest exponent of one in the polynomial is going to give you the degree of the polynomial. And the term that has that highest exponent is called the leading term. So it doesn't matter if you wrote it the 5th into the list of the monomials that make up the polynomial. The term with the highest exponent is called the leading term. So we're going to talk about how these are classified. So I'm going to look at what's on the margin over here first. We classify by degree. So this is the powers, the exponents we're talking about, the highest exponent. So we've got constant when there isn't an exponent at all, or I should say when the exponent is 0. So there's no variable. It's only a numeral. If the variable has an exponent of 1, then it's linear. If the variable has an exponent of 2, it's quadratic. With a 3, it's cubic. With a 4, we call that quartic. And 5, we call that quintic. So these get, and there are names for all the other ones, but we typically don't use anything above quintic in our classes here. Now the number of terms, when there's only one term, it's a monomial, which is what we just got through reviewing. When there are 2 terms, that's binomial. So this was monomial, 1 term, bi, 2 terms, tri, 3 terms. Poly just means more than 3. So when you have 4 or more terms, we just say polynomial. But 1 term would be monomial, 2 terms binomial, 3 terms trinomial. So problem number 9, we've got 3x plus 1. That variable has a degree of 1, so it's linear. There are 2 terms, so it's a linear binomial. This right here, the highest degree is 5. That's quintic. And there's 1, 2, 3 terms, so it's a quintic trinomial. 24 is a type of polynomial. It doesn't have a variable showing, so that would be x to the 0 power. meaning there's just the numeric, which is constant, and there's one term, so it's a monomial. We move on to page 3 of the printed notes. This is where we're going to review adding and subtracting, multiplying and dividing of polynomials. So in adding and subtracting polynomials, you want to combine like terms. All of the variable, the exponent has to match. So you cannot add or subtract x squared and x cubed. You can only add up x squareds with other x squareds. You're counting how many x squareds. So in this problem, I'm saying I have 3x squareds and 1x squared. So that's a grand total of 4x squareds. I have 11 x's and I want to add negative 5 x's. So that would be 6 x's. When we're all done with that, we have that. And once again, over here, I combined like terms. So you have this. It's best if you at least looked at the problems on the website, pause this video, try to do the problems if you don't have the handout, and then double check your work, because this is topics we've done before, and we're really just reviewing them. So we've got 2 different subtraction problems. You pause the video, try them out, and there's the answers after we collected like terms. That's the end of that part of it. There was a big space here, so I just put a little happy face. Now, we're going to talk about multiplying and divide. Well, just multiplying polynomials. Distribute is the rule. Sometimes you hear the word FOIL. You really only did FOIL when it was one binomial times another binomial. Distribution is really what we're doing. So you're going to, and then you're going to combine like terms. Write your answer in standard form, meaning descending order. So in doing this problem, I'm going to do the distribution, and I'm going to do it in such a way it'll be easy to combine like terms. I'm going to take the W in this binomial and multiply everything in the trinomial times the W. So you end up with this. Now, the next line right below this, I'm going to multiply everything times negative 7. When we multiply it times negative 7, we get this. And when I did this, negative 7 times W squared, I wrote it in the column under the other W squared. When I did negative 7 times 2W, excuse me, I was confused what I wrote there. Negative 7 times 2W, that's going to give me negative 14W. And I wrote it in the column where I already had a W. And then negative 7 times 1, I put that in the far end. Now I just combine like terms which are already in columns, and we end up with this. And over here you can see I did the same idea. This time I did 3c squared times each one of those. I got this one. Then I multiplied the negative 4c times all of the terms in that trinomial and wrote it on this line. Again, lining them up in each column. And lastly, I did 1 times everything there, and there it is, and combine like terms. So staying organized so that you can combine like terms will really help you. Now this time, I've got 3 groups here. So I'm going to do this. I'm going to start off by multiplying negative 3 times a plus 5. Then I'm going to multiply these 2 binomials here. So I end up with this. It's a lot easier. Now I'm going to do just like I did up here, negative 3a times everything there. And then I'm going to multiply negative 15 times everything in that trinomial. And I already lined everything up in columns. And I have my final answer. For this one, it's very similar to this problem here, except it says cubed. So I wrote out each group 3 times. I multiplied these 2 together and got this one. Now I'm going to distribute and collect. And our last page of review is about division, but we're starting off kind of slow. We're going to talk about dividing polynomials only by a monomial. So we're going to divide each term in the numerator by the monomial. So this is we're only dividing by one term. So in well, it's revealing both at the same time, but I'm dividing 9m cubed by 3m, and I'm also dividing 24m squared by 3m, and then they're subtracting the two of those. So writing it out is much more helpful than if you start crossing this out, you might make a mistake. Remember that every term is being divided by that monomial, and then we simplify. And then I did the same thing over here, where I was dividing by 4x. Now, this next one, it says I'm multiplying, except that multiplying by 2ab to the negative 1 is the same thing as dividing by 2ab to the positive 1, because this negative 1 power is like putting it in the denominator. So we are actually dividing when it has that power of negative 1. So here I wrote it out where I'm dividing every single one of those terms by 2ab and then simplifying the problem. And over here I did the same idea, each term with the divisor under each one of them and then simplified. So that is your review of polynomials and monomials, and you have homework of doing more of these types of problems.